All right, this is our continuation of yesterday's stuff. Let's see here, and this stuff will show up on your quiz. You want to be ready for it. From yesterday, this is the kind of stuff we saw. Inverse of tangent. The tangent of what angle is going to give us 0 is what they want to know. Now, if it's 0, it's probably some sort of quadrantal. Remember, for tangent, you're only allowed to use negative pi over 2 to pi over 2. First and fourth quadrant. What's that angle going to be?
0 degrees?
0. 0 degrees, or 0 radians. Cotangent. The cotangent is -1. Cotangent is only allowed to be from 0 to pi. And if it's negative, it means it came from this quadrant. Yep, you're right. Cotangent's -1, or adjacent over opposite. This should look familiar for a 45-degree angle. Unless they tell you otherwise, you need to put your answer in radians. So rather than saying 45, we're going to call this pi over 4 right there. But they want to know the positive, like the long way around, what that is. It's 3 pi over 4. Good. All right, here's your challenge. You've seen these before. It's just been a while. If it's the inverse of a trig function, you're looking for an angle. So they want to know the secant of the angle for this guy. They do. Secant and the inverse of secant are, they're the inverses of each other, so it's like they don't even exist. So the answer is just 2. If you weren't sure about that, or if those trig functions did not match, you can still draw the triangle. Secant and cosine, you can go from 0 to pi. It's positive, so it's in the first quadrant. Secant is hypotenuse over adjacent. So this is a 1, 2, radical 3 kind of deal, but it doesn't matter. It doesn't matter what that angle is, because they want you to find the secant in this triangle. So hypotenuse over adjacent, it's still 2. Okay? All right, today's stuff. They're going to want you to graph these things by hand. Now don't stress, it's really not that bad. Before you graph an inverse, here's what I'm strongly suggesting. I think you need to turn this into just the regular graph. And let's talk about this. Cosine is in the first and second quadrant, right? That's what you're allowed to do for the inverse, first and second quadrant. So for first and second quadrant, I'm thinking that's 0 to pi. And I want one more dot in there. So I'm going to do half a pi. Let's solve for y. Cosine of 0 is? What's the cosine of 0 degrees?
1.
1, thank you. Cosine of pi over 2? 0. And cosine of pi? -1. Inverse is just where you swap the x's and the y's. That's what we said yesterday. So for this guy right here, I'm going to write a new t-chart. And I'm just going to flip-flop them. Rather than having 0, 1, I now have 1, 0. Instead of pi over 2, 0, I've got 0 pi over 2. Instead of pi -1, I've got -1, pi. Then we graph it. Up until now, on the x-axis, we've been writing radians. This has been angles. That's now on the y-axis. So I'm going to call this pi. There's pi over 2. Here's negative pi down here. The y-axis previously has been 1, 2, 3, 4, 5, so now that's going to be on your x-axis. These are just regular old numbers. Whoops, how about -1? Sorry. And then you graph it. Here's my inverse t-chart, so this is just like middle school math. You just graph the t-chart. So I have 1, 0. Let me get a different color. 0, pi over 2. And -1, pi. It's not a straight line. I know it looks like it, but remember, this is the graph of cosine, and it's been reflected over that line, y equals x, so you know it's curved. Here you go. That's it. questions on this first one? Why did I do what? This one goes with this one. And then I swap the x's and y's, and so the inverse goes with this one. So I graph the inverse. Does that make sense, Alex? Okay. The second guy. Now before you start to go, oh, I can put myself on autopilot, I totally get this now. Do not change this to y equals 2 times sine of x. This means you're doubling the inverse, not the original. So we need to undo this. It's going to be half of the angle, actually. So you can go ahead and flip-flop this x and y if you want to. And let's solve for y. First step, divide everyone by 2. So I have x over 2 equals the inverse of sine. To undo an inverse, it's just back to the original. So it's sine of x over 2 equals y. And that probably messes with your brains a little bit. Most of you guys like the y on the left. So I'm going to call this y equals, and instead of saying sine of x over 2, I think most of you guys will do better if I put 1/2 x. It means the same thing. But most of you appreciate looking at that better. All right, so let's make our t-chart for that equation. So it's sine. We learned yesterday that for inverse, sine can be in the first and fourth quadrant. And they're picky about that fourth quadrant. You can't call it 3 pi over 4, or 3 pi over 2, sorry. You can't call it 3 pi over 2. It's got to be negative pi over 4. I mean, good night, what is wrong with me? Negative pi over 2, sorry, that's negative 90 degrees. And so it's between negative pi over 2 and pi over 2, so halfway between that is 0. Let's just find 3 points. So we're going to plug those x's in and solve for y. Negative pi over 2 times 1/2 is negative pi over 4. What's the sign of negative pi over 4? There you go. Negative radical 2 over 2. Let's plug in 0. Half of 0 is 0. What's the sign of 0? 0. That one's easy. Pi over 2, let's plug it in. Half of pi over 2 is pi over 4. What's the sign of pi over 4? Yep, radical 2 over 2. Now the problem with this is whenever I flip-flop it and then I try to graph it is, I don't know where that is on the graph, and neither do you. Let's make that a decimal real fast so we can kind of know where we need to graph this thing. And I'll save you some time because I know you guys are anxious to kind of get to your assignment and talk about your quiz for tomorrow. Trust me, we looked this up earlier today. It's negative 0.707, and this one is positive 0.707. All right, so let's do the inverse now, which they said was y equals 2 times the inverse of sine. So now we're going to swap our x's and our y's. You guys okay? So we just flip-flop them. Rather than saying negative pi over 2 is x, negative pi over 2 is now y. Instead of saying x is negative 0.707, it's instead of saying y is that, now it's x. So we're just flip-flopping everything. They're swapping places. And now this is what we're going to graph. So we draw our little deal. Here's 1. Here's -1. Here's pi over 2. Here's negative pi over 2. My first point is negative 0.7 comma pi over 2. So negative 0.7 comma pi over 2. 0, 0. And wait, negative pi over 2. Crap, I thought that was weird. There we go. And then 0.7 and pi over 2. It's not a straight line. Got to curve that thing, and it needs to be curved probably the correct way. If you remember, sine used to do this, and you need to reflect it over this line. So that's going to make that curve. Whoops, I didn't do a very good job of that, did I? Sorry. So it makes that curve do this. Don't put arrows on the ends. The domain is they're very picky about that. Also, we need to take a look at our chart from yesterday to kind of determine if those are open or closed circles. Some of those are equal to and some of them aren't. Do you guys have your notes from yesterday? You grab them real fast, or you can look up here. For sine, it's equal to. Cosine, where you graphed out, it's equal to. I think the only ones that aren't are tangent and cotangent. So those are going to be open circles, just so you know, for tangent and cotangent. Okay? Questions on the graphing piece?
Wait, okay, so, when you, like the normal sine graph, that's like horizontal, whatever,
Yes.
whatever you said that you reflect it.
Over this line, y equals x.
Yeah, so like, why does it start at the positive one?
Because if you, I don't know how to zoom this in. Let's see here. Sine kind of looks like that, right? So if whoops, sorry, Sarah. So if I'm reflecting it over this line right here, then the mirror of that, Sarah, is going to do this.
Okay.
You know what I'm saying?
Yeah.
Great question, though, because that is tricky. It's hard to see. Great question. All right, so that's the graphing. Probably not the most fun you've ever had, but you can do it. All right, here's some stuff that'll show up tomorrow. They want to know the cosine of the inverse of sine of 2/3. If it's asking for an inverse of a trig function, inverse sine, what's it asking you to write down? You're solving for an angle, right? Exactly. So this is actually asking you for cosine of whatever angle this is. Triangles are going to help you out. Sine, the inverse of sine, can either be quadrant 1 or quadrant 2. 2/3 is positive, so what quadrant is that? 1, right? Sine could be first or fourth. It's got to be first because sine is positive. Remember, 2/3 is not an angle. That's the answer to sine of the angle. So sine, the answer is 2/3. So opposite over hypotenuse. Use Pythagorean theorem to figure out the third side. And you're going to get radical 5. And now that you have your triangle, it doesn't matter what theta is. Because you can look at the triangle and figure out cosine of that theta. What is cosine? Adjacent over hypotenuse. That's radical 5 over 3, right? You guys good? Do I need to slow down? Yeah, do I need to do this again for you guys? So we have 2 squared plus whatever the x squared was equals 3 squared. This is 4 plus x squared equals 9. Subtract 4. Sorry, I was just trying to save you time because I've done it a couple times today. And I know you guys can do that. Questions on A? Can I move on? Okay. Next one. Secant of the inverse of cotangent of negative 15/8. You're going to do it the same way. Cotangent, guys, can be in what quadrant? First or second? It's negative, so where is it? Second. Draw the triangle. Cotangent is adjacent over opposite. What's the third side? Do you know that magic triangle? There you go. They want to know the secant of this angle. So, hypotenuse over adjacent. Negative 17/15. Can you guys handle that tomorrow on your quiz? No? McCormick, where'd you get lost? You're okay? From here, you draw the triangle with that information, McCormick. You with me?
Yeah.
And then once you have your triangle, find the secant of it. You're good? You sure? Okay, moving on. There's a typo. You guys need to put sine in front of this. Sorry. So this one is sine of the arctangent of 4/3 minus the arc cosine of 12/13. Now Lucas reminded us that if it's the inverse of a trig function, you're looking for an angle. So this is asking for the sine of, this is one angle, minus this is another angle. Do you know what to do with that? You're going to whip out those identities. I'll have it on paper. So this is the difference identity, guys. So that equals sine of x cosine of y minus sine of y times cosine of x. That's an identity. So we need to draw triangles for both of these guys. If we're going to call this angle x and this angle y, we need a triangle for each of them. Tangent, and it's positive. That tells me first quadrant. And tangent of x, it says, is 4/3. So that's a 3, 4, 5 triangle. Next angle, angle y, cosine, and it's positive. So that's first quadrant. Cosine is adjacent over hypotenuse. Is that a magic triangle? Yes. 5, 12, 13 triangle. So now we just fill in the blanks. Sine of x, here's x. Sine, opposite over hypotenuse, that's 4/5. Times cosine of y. Here's angle y. Cosine is 12/13. What do I write next? Marina's got it. It's 5/13 times, what's cosine of x? Whoops, what is it? There you go, 3/5. Please don't cancel out these 5s. You can, but you're going to be sad. You want common denominators. So 4 times 12 is 48. 5 times 13 is 65. Minus 5 times 3 is 15. 13 times 5 is 65. And because they're common denominators, you just saved yourself some time. 33/65 is your answer. Questions on letter A. You have to be able to recognize the identity. Once you get that far, I think you guys will be fine. Letter B. Again, we have our cotangent. So this right here is representing some mystery angle. So this is saying sine of 2 times some angle. Dun, 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 identity, right? So it equals 2 times sine of theta cosine of theta according to your pink sheet. We need a triangle. All right, McCormick, you're the one that had questions about this. It's cotangent and it's negative. What quadrant is that? Spencer, do you know? There you go. Cotangent could be first or second quadrant, and it's negative in the second quadrant. So my point is, you guys need to know that little picture we drew yesterday. You need to know that. Cotangent is -5. Cotangent is adjacent over opposite. Pythagorean theorem, get you the third side. Trust me, it's radical 26. Now use the triangle to fill in the blanks. 2 times. Alex, what's sine of theta? How do you find sine? You do SOHCAHTOA. There you go. Opposite over hypotenuse. Yeah. So 1 over radical 26. Please do not rationalize that. You're going to see why in a second. Cosine is adjacent over hypotenuse. So -5 over radical 26. Just multiply them together. 2 times 1 times -5 is -10. 1 times radical 26 times radical 26 is 26. And reduce. How you guys doing? Emily, you okay? I can't tell if you're being sarcastic or not. Let me ask you this, Emily. Do you know how I got from, do you know where these numbers came from? Okay, it says sine of theta. Here's theta.
No, wait. I understand that.
Okay.
But I don't know.
Do you know where this came from, the triangle?
No, I got that.
You do have that?
Yeah,
Okay. Do you know where this came from?
yes.
Okay, then do you know where this came from? That's an identity. That's why. This equals this on your pink sheet.
Okay.
So can you handle the rest? Maybe?
How, what, like whenever you did 2 times that, when did that, when,
Well, it's 2 over 1 times, like you multiply the tops and then multiply the bottom. Yep. Okay. Questions? Was it the second quadrant? Because anytime it's asking for arc cosine, arc sine, arc cotangent, whatever, it's the inverse. So it means it's asking you what's the angle. It's like there's a question mark saying what's the angle, Heidi? So anytime you see arc or to the -1, it's the inverse little symbol, it means what's the angle. So that's what they're asking for. Good question. Is everybody okay on this one? Letter A. So Emily, do you see where I got this? Here's sine. This is asking for an angle, we're going to call it x. This is asking for an angle, we're going to call it y. And this is an identity. It's the difference identity on your pink sheet. Are you okay? Okay. That's kind of sketchy. Okay, last little bit. Guys, when you get to these on your assignment, it is the exact same process. Don't freak out because it's a letter. It's just a letter. If it says, what's the cotangent of the inverse of secant of u, they're just going to give you a number. Process is the same. They're asking you for the cotangent of some mystery angle. Let's draw the triangle. It looks like u is positive and it's secant. Secant means that we're either in the first or second quadrant and it's positive. So we're in the first quadrant. So let's just draw a triangle in the first quadrant. Secant is hypotenuse over adjacent, yes? You with me? And u is over 1, every number is. So hypotenuse over adjacent. You're going to find the third side just like you always find the third side. Pythagorean theorem. So we have 1 squared plus whatever that is, we'll call it y squared, equals hypotenuse squared, so u squared. We got to solve for y to figure out what that side is. So subtract 1 from both sides and square root both sides. And don't you dare say that the square root of that is u minus 1. It's not. U squared minus 1 means u plus 1 times u minus 1. If you try to turn that into u minus 1, I don't know, one of these posters over here, you've just killed a puppy, I think. So watch it, okay? Every time you do that, a puppy dies.
So u plus 4.
It is what it is. It is that gross thing.
Would it not be?
No.
U, yeah,
Don't do it.
minus u plus 4.
What is the square root of 1?
Do it.
What is the square root of 1?
It's like I or something.
It's 1.
It's 1.
Oh.
So it's still not u minus 1. Still not.
So it's negative u minus 4. Radical
Is it
negative
what?
U plus 1 times u minus 1.
So you're not multiplying anything that's the same, so you can't pull the radical out. So we've got our triangle here. It's asking for cotangent. Cotangent is adjacent over opposite. So it equals 1 over big ol' radical of u squared minus 1. To rationalize it, multiply it by the square root of u squared minus 1 over the square root of u squared minus 1, which looks really crazy, but it's not a big deal because the top is itself. And the bottom, the roof just pops off. If you had radical 5 times radical 5, it would be 5. So you have radical a mess times radical of the same mess, it's just the mess. The roof comes off. And that's it.
So you can't.
Nope, that's as far as it goes. That's all you can do. So I know it looks bizarre, but it's the exact same process we've been going through. Last one. Sine of 2 times the inverse of cosine of u. Inverse right here is asking a question. It's saying, what's the angle? So we're looking for the sine of 2 times some mystery angle. Triangle's next. Jacob's right. So we've got cosine of positive u. Cosine is first and second quadrant. Positive would be first quadrant. If cosine is u, cosine is adjacent over hypotenuse. Pythagorean theorem. U squared plus y squared equals 1 squared. Solve for y, so we subtract u squared from both sides. Square root both sides. And it is that yucky thing. Once you have your triangle set up, let's go back and see what they're asking for. They want the sine of 2 times that angle. This is an identity. It's on your pink sheet. Yep, you got it. 2 sine of theta, cosine theta. So I've got 2 times sine of the angle. Look at the triangle. Sine is opposite over hypotenuse. Times cosine of theta. Cosine is adjacent over hypotenuse. Now you just need to put it in a pretty order. Should be 2 times u times the radical. And that's it. Okay. So you should be set for your assignment. And let's see, what time is it? 12:20? Let's talk about your quiz first.